First off, I want to say this isn't going to be like a lot of my videos. This is a video about ham radio. A lot of people have asked me some questions about ham radio, and I just kind of wanted to make a video that lays it all out, all the basics that you need to know. If you don't care about that, this probably isn't the video for you. For those of you who do care about that, this is the video for you. So let's get into it. So like I said, a lot of people have asked me to do a video breaking down ham radio as a form of communication if there's ever any kind of infrastructure problems. In addition to ham radio being the best option for communications during certain types of emergencies, it's also a great way to connect with people around the world that often have above average IQs and sometimes share a lot of our values. So the reason for this is, like the internet of old, it's not as easy as just smashing your fingers on a government-issued screen. Kind of like the Wild West days of the internet, it requires a level of technical proficiency that a lot of people aren't going to bother to dive into, and quite frankly, a lot of people are just incapable of grasping. Another reason I think it's important that people participate in ham radio is the vast majority of the user base is dying off because the internet now exists, especially when it comes to voice transmissions, which is the majority of what I'm going to be covering today, and it's going to be the most important if there's ever any kind of emergency. First off, what is ham radio? An easy way to explain ham radio would be to say it was the internet before there was an internet, with one significant difference. Just like the internet, ham radio allows people to communicate all over the globe with voice communications, digital text, or even email. But it doesn't require an infrastructure. Ham radio is regulated by the FCC and by other organizations like the FCC in other countries, but there's no ham radio cutoff switch. You're not dependent on companies to provide ham radio for you, or the government to allow ham radio transmissions, although I'm sure that they do have the ability to jam to some extent. But for the most part, if the entire communications grid went down, or even if the electrical grid went down, you're only limited by the equipment that you have and by the equipment that the other people that you're talking to have. You're not dependent on third parties. Other things like weather conditions, time of day, and even solar activity also have an effect on your ability to communicate. But a lot of that, most of that is going to be beyond the scope of what we're going to cover today. For the most part, it's just understand that ham radio gives you the ability to talk to people all over the world without having to use a third party. So let's talk about the difference between HF and VHF, UHF, because when it comes to emergency communications, this will make a huge difference in your ability to actually communicate with people. In this video, I'm mostly just going to break everything down in the simplest ways possible. Some of that's still going to be a little complicated, but I'm going to try to keep it as basic as possible. There are tons of resources for people that want to get into the technical aspects, the nitty-gritty of what I'm talking about, but this is just the bare bones basics, so that if you decide to get into ham radio, you're not just flying blind and just buying stuff that you later find out doesn't work at all for what you're trying to do. Generally speaking, HF, or high frequency, is for long distances. VHF and UHF, or very high frequency and ultra high frequency, is for short distances. Now, the reason for this is when you transmit an HF signal, the signal bounces off the ionosphere and makes a series of hops around the world until eventually it runs out of power and gets lost in the noise. When you transmit a VHF signal, rather than bouncing off the ionosphere, it just punches right through it, just like the microwaves in your microwave oven, which are even smaller waves, penetrate your food. It just blasts right through the ionosphere and shoots off into space, and you're not talking to anyone unless there's aliens out there. In fact, as a side note, this is the same reason why some people are concerned about 5G, which I'm not really going to get into that, but I'll maybe explain a little bit of why they have that concern. Because 5G is even higher frequency, and same sort of thing. It just punches right through stuff. The higher the frequency, the shorter the wave. And more or less, the more likely it is to penetrate objects rather than to bounce off of them. Now, a common HF signal that would bounce off the ionosphere and allow you to talk to people several hops away would be 7.25 megahertz, which is a wave that's slightly longer than 40 meters in length. Now, by contrast, a common VHF frequency might be 146 megahertz, which is only 2 meters long. A common frequency that's used for cell phones is 1,900 megahertz, which is really small. It's only 0.16 meters, so 1.6 centimeters. Smaller still are the radio waves used in your microwave oven. And that's right, microwave ovens, all they are, they're just radio transmitters. They're just blasting your food with radio waves at a frequency usually of 2,450 megahertz. And that wave is even shorter. It's about 0.12 meters, or just over 1 centimeter. So the radiation from these radio waves in your microwave, it's punching through your food and heating it up. 5G uses an even smaller wave. That's 86,000 megahertz, or 86 gigahertz. And those waves are 0.0035 meters. So they're just really tiny. And they penetrate lots of stuff. Going back to VHF and UHF ham radio signals, they don't bounce off the ionosphere, generally speaking. Just like the radio waves coming from your cell phone, like your cell phone is just another radio. Your cell phone communicates with the cell phone tower the same way that a UHF ham radio communicates to an antenna. And these shorter radio waves, because they don't bounce off the ionosphere, they can only reach people through line of sight. In other words, you need a straight shot between you and the antenna. These higher frequencies, these shorter waves, they can pass through some objects. That's why your cell phone, it'll still work if you're inside of a building. But they do have trouble passing through metal, which is also why they tell you not to put metal in your microwave. But even though these waves will pass through like the bricks in a wall, they will get weaker the thicker the object is, which is why sometimes your cell phone might not work if you're inside a building like a parking garage. So even though these shorter waves, they punch through things, they lose power the thicker those objects are. And that's why VHF and UHF radios and your cell phone need a clear shot at the antenna they're communicating with. We're going to get to the part that the flat earthers are going to lose their minds about, because these limitations of radio actually give us some pretty conclusive scientific evidence about the shape of the Earth. Now, the reason why cell phone towers or even transmitters for radio and television stations are placed as high as possible, like on mountaintops, on tall buildings, is that eventually the signals will reach the curvature of the Earth. And they'll lose too much energy to punch through to the other side. In fact, this is so measurable and so easy to predict using the math about the curvature of the Earth. There's a formula that you can use that will very accurately predict how far you'll be able to transmit based on the elevation of your antenna. The higher up it goes, the further you can reach because you're overcoming the curvature of the Earth. So all these experiments that people are trying to do to determine if the Earth is flat or not, all you really need to do is put up a radio antenna and transmit and then drive away from it and do the math. And, obviously the terrain will matter a little bit, but I don't know why no one's done that. Maybe that's something I'll do. Maybe I'll do a video where I'll put up an antenna and I'll start it broadcasting and I'll just drive away on the area I'm in is relatively flat. There's some mountains and stuff, but maybe that's something I could do because it really doesn't go that far before the curvature of the Earth gets in the way. But anyway, this is also why these VHF and UHF radios are not suitable for a lot of emergency situations. To get around these limitations, people have created repeaters. Now, a repeater is just a really tall antenna somewhere. It's like a central hub that uses a well-placed antenna that more people can connect to that just repeats signals to the other people that can also see that antenna. In fact, the modern repeaters are even connected to the internet. So people can talk between different repeaters in totally different parts of the world. A repeater in Japan could be connected to a repeater in London. But really, the only thing that's radio at that point is the connection between the individuals in each city talking to that central hub. The obvious problem here is that it's relying on infrastructure. If the internet goes down, or even power to the repeater goes down, you're just limited at that point to who you can reach directly, which isn't going to be very many people unless you have an antenna that's mounted on a very tall building. And even then, you're limited by the curvature of the Earth. That's as far as you're ever going to get with these UHF and VHF. Now, if you want a real-world example of this working in a way that you might have personally experienced it, let's just take a look at AM radio stations versus FM radio stations. Now, there's an AM radio station called 770 KOB in Albuquerque, New Mexico. It broadcasts at 0.77 megahertz. That's a very long wave. It's about 390 meters long. And when atmospheric conditions are right, and usually at night, you can hear 770 KOB crystal clear in Flagstaff, Arizona. And the way it's overcoming the curvature of the Earth is it's bouncing off the ionosphere because it's that longer wave. Now you can contrast that with that exact same station is also broadcast on an FM radio station. It's broadcast on 94.5 FM. And 94.5 FM is 94.5 megahertz. And that's a much, much shorter wave. It's 1/100th the length of the AM radio station. So it's just barely over 3 meters long. So it's a much, much shorter wave. And even though these are both radio stations broadcasting the same thing out of Albuquerque, you'll never hear 94.5 FM in Arizona at all, or even really much outside of Albuquerque, because as soon as it hits the curvature of the Earth, that's it. It's dunsies for that. So to recap, VHF and UHF, they're only good for local line-of-sight communications. Even when they're used for these purposes, you're often relying on a repeater or some kind of hub that is like a go-between between you and other radios because it is so short distance. Now, this doesn't mean they're completely useless. They make great short-distance handheld radios. So if you need a way to communicate with people locally, people down the street, people that aren't that far, a VHF or UHF radio is the way to go. The reason I spent so much time explaining the difference is lots of people go on eBay and they see these cheap little Baofeng Chinese ham radios for like $20. and they think, oh, I've got a ham radio, problem solved. And then even worse, they'll get this radio and they'll just throw it in a box with all their other emergency stuff like flashlights and ammo, and they'll just expect to know how to use the radio if there is an emergency. Maybe because they played with a CB or a walkie-talkie when they were younger, and they just think that, it's the same thing. You just turn it on and change the channel, and away you go. And that's only true if that's how you plan on using it. If you're just talking to another radio that's also tuned into the same frequency. And at that point, you might as well just be using a walkie-talkie. Because without doing at least some basic research and finding out information about your local repeaters, you really can't, just like you can't connect to your neighbor's Wi-Fi without the password, you need to program your radios to talk to your local repeaters. Now, all that is way beyond the scope of this video, but I just wanted to make that distinction here, that if you get one of these little handheld, quote-unquote, ham radios, they're kind of useless unless you're just using it as a walkie-talkie if there's any kind of significant infrastructure failure. Because it is, at that point, it's just a walkie-talkie. That's all it is. So VHF, UHF, really only good for really local communications. So now let's talk about HF. Now, while you're not connecting to hubs or relying on infrastructure to communicate on HF, you also can't just go buy an HF radio and expect to be able to start talking to people on the other side of the planet as easily as you would talk to someone on a CB or a walkie-talkie. There are lots of things you need to take into account before using an HF radio effectively. The first thing you need to understand about HF is you need a good antenna. You can have the most expensive HF radio in the world, but without the right antenna, you're not going to be able to hear anybody, and no one's going to be able to hear you. In fact, the antenna is more important than the radio. So we'll get into all that, but before we get into antennas, you need to first understand which frequencies HF has and which ones you'll be using, and I'll explain why here in a second. So the FCC has given amateur radio operators different ranges of frequencies or bands to be exclusively used for ham radio. There's like one, we're not even going to talk about it though, that you share with other people, but the ones we're going to talk about, they're exclusively for ham radio. Each one of these bands is a range of frequencies with a different length of wave. So because these waves are different in length, they react a little bit differently with the Earth and with the ionosphere, and you get different results. And again, I'm just going to be really basic about this and keep the technical stuff out as much as possible. We're just going to focus on the results, the real world application as much as possible. Okay? So some of the more popular bands used for voice communication are 160 meters. So 160 meters is 1.8 megahertz to 2 megahertz. So it's just barely above the AM radio broadcast frequencies. And because it's really close to AM radio in frequency, it behaves very similarly to AM radio. It requires very large antennas, and you really don't get very far during the day, but it's fairly local during the day, and then you get long distances at night, just like you would with AM radio. Because you need such a long antenna for 160 meters, there's really not a ton of traffic, or at least in compared to other bands. So 160 meters is not really as important. More important would be 80 meters. 80 meters is 3.5 megahertz to 4 megahertz. In my experience, 80 meters doesn't work too well during the day, but at night, I've made contacts 1,000+ miles away using relatively low power. There are considerably more people talking on 80 meters than on 160 meters. And if you want long distance emergency communications, you definitely want to make sure that your radio, your setup, is capable of 80 meters. Think of each of these bands as different chat rooms, and 80 meters is probably the most popular one at night. And you run into some pretty interesting people. Next, we have 40 meters, and that's 7 megahertz to 7.3 megahertz. 40 meters seems to give you the most well-rounded results in terms of being able to communicate clearly in the day and at night. You get longer distances at night than you would during the day, but you still get relatively long distances with both. With my setup right now, which is kind of thrown together and not much different than it would be in a improvised emergency situation, I'm able to get about 400 miles during the day and consistently, and over 1,000 miles at night without a lot of trouble. So 40 meters is probably the most popular band because it seems to work the best. So any ham radio setup you want to do, you definitely want to make sure you have 40 meters. That's probably going to be your go-to band on ham radio. 80 meters and 40 meters are probably, those are the two most, in my opinion, the two most important bands to have in like an emergency situation where you want to be able to talk to people long distances. Okay, so next we have 20 meters, or 14 through 14.35 megahertz. This is a band I haven't personally had a lot of luck with, which probably has a lot to do with how the band is affected by the solar cycle. Right now, conditions on this band, and even more so on bands I'm going to mention later, are really being affected in a negative way by the solar weather that we're having right now. The where we are in the solar cycle affects the radio wave's ability to interact with the atmosphere and do its thing. But when solar conditions are good, 20 meters is where it's at for really long range, long distance communications. And even now, when conditions are just right, and you'll have these little windows of time where 20 meters opens up, and you can really contact, you can go all around the world with very little power on 20 meters with the right equipment, the right antenna. It's just not something I've been personally successful with, and it's not something that in emergency situations would probably work too well, at least right now. Maybe when weather or solar weather conditions change, and that can take years, that will change. But as of right now, 20 meters is really not going to be where it's at. 17 meters, or 18.068 megahertz through 18.168 megahertz is pretty much like 20 meters. And same thing, haven't had a lot of luck with that. 15 meters and 12 meters are just like the previous two, but they're even worse in terms of the solar cycle affecting them negatively. And again, my experiences of they've been pretty much completely dead. I'm sure people with better setups and more experience will have better luck, but generally speaking, 15 and 12, for me at least, are pretty much useless. 10 meters, same story, which is unfortunate. 10 meters is 28 megahertz through 29.7 megahertz, and it is the most affected by the solar cycle. But when it does work, which isn't very often right now, you can make it all over the world with like 5 watts of power. So all in all, I would say that 20 through 10 meters right now, they could be crucial if in the right situations, with the right conditions. But generally speaking, you're at the mercy of the solar cycle. So if you're just looking to have something that's going to be more reliable, I would say that those bands should come secondary to 80 and 40 meters. Okay, so the reason I took the time to go through all of these bands, wavelengths, and frequencies is depending on what band you're on, depending on what frequency you're on, that's going to inform what kind of antenna that's going to work. The type of antenna that you have affects your ability to transmit and receive dramatically. In other words, if you have an antenna optimized for 80 meters, it's not even going to work on 10 meters. Suffice it to say, the longer the wavelength, the longer the antenna. But by the way, that's also why your cell phone that operates on a much shorter wavelength, wavelengths we discussed earlier that are less than 2 centimeters long, the antennas in your cell phone can easily fit inside your cell phone because the wavelength is so much shorter. But if you're talking on an 80-meter wavelength, you need a much longer antenna to transmit that wavelength and to receive that wavelength. I'm not going to go into all the different kinds of antennas, but the reason you have to understand this relationship between frequency and antennas is that obviously for those of you who live in an apartment, having an antenna that's 133 feet long isn't very practical. Now, luckily there are some ways around this, but they can be pretty expensive, even if you make the antennas yourself. The first option is called a magnetic loop antenna. You can make them yourself. I made mine myself, and it did work on 80 meters on my apartment balcony. It's not ideal, but there are options like that. You can also, in an emergency situation, you can wrap a longer wire around your building. You can drop a wire out your window or string them up in a tree. Just keep in mind that if you're doing that, these antennas are emitting radiation. So if you drop an antenna out your window in a high-rise, for example, and you start transmitting, you're basically blasting all the neighbors that live below you with radiation. So that's just something you got to keep in mind. The basic thing you need to understand here is if you really want to get into HF, the antenna is a big consideration. That's something you really need to understand more than anything else. The antenna is the most important element of a ham radio station that you could basically say consists of 4 different elements. So the antenna tuner, which we'll talk about in a second, the radio itself, and the power supply. So we just talked about the antenna. Let's talk briefly about the antenna tuner. Now, many newer radios will have a built-in antenna tuner, but many don't. And older radios, pretty much none of them have built-in antenna tuners. So it's important that you check for that and you make sure you get an antenna tuner because, as we discussed, the length of the antenna is dependent on which frequency you're on. And the length will change within a single band. So, for example, let's say you're on the 80 meters band. So that's 3.5 megahertz through 4 megahertz. Now, that's a difference in wavelength from about 85 meters at 3.5 megahertz to about 75 meters, which is roughly 4 megahertz. So you're talking about a difference of about 10 meters in length. So depending on what frequency you're tuned into on that band, there could be a 10-meter difference in wavelength. And so that significantly changes the length of the ideal antenna for that frequency. So the way around this, because you can't, every time you change your frequency, you don't want to go out and like cut the antenna shorter or splice on another wire to make it longer. So the way to get around that without going through all that hassle is to use what's called an antenna tuner. The easiest way to explain what an antenna tuner is simply that it's a device that artificially changes the length of the wire that you're using as an antenna. From an electrical standpoint, the wire is getting longer and shorter using capacitors. It tricks the radio into thinking that the wire is getting longer and shorter based on how you tune the antenna tuner. That said, antenna tuners have their limits. You won't get a whole lot of success if you try to tune an antenna that's made for 10 meters, if you try to tune it all the way up to 80 meters. There's tuners where you can do that, and it'll kind of work, but it's not going to do a very good job. So while antenna tuners will give you some leeway on the length of your antenna, they do have their limitations. And again, there's a ton of information out there about tuners and how they work from a technical standpoint, but we're not going to get into any of that. It's just mostly important to keep in mind that if you're trying to set up a ham radio station, you need to get an antenna tuner or make sure that your radio has a built-in antenna tuner, and make sure that the antenna tuner that you get is rated for whatever wattage that you're going to be putting into it. So if you have like a 100 watt radio, your antenna tuner has to at least be rated for 100 watts or more. Beyond that, there's a ton of information about antenna tuners, but that's just the basics. So now let's talk about the radio itself. There's a lot of things to keep in mind when you get a ham radio. And again, I'm not going to go into every little single detail, but let's cover some of the basics. So the first thing, obviously, is that it covers the bands that you want to use. Not all radios cover all bands. And some radios only cover one band, like the real cheap ones. So make sure that the radio that you're getting covers the bands that you want to talk on. A lot of the modern radios will cover all the bands unless you get the really cheap single band radios. So it's not like a big deal, but just, it's something to be aware of. Secondly, you need to make sure that the radio covers all modes. And again, the modern radios typically are going to cover all modes. But let's just briefly cover what the modes are anyway. The two most common modes for HF that most radios built since the 60s will have is upper sideband and lower sideband. And those are two halves of single sideband. Single sideband, upper and lower, is mostly what is used on HF. We're not going to talk about the technical specifics of what upper sideband or lower sideband is specifically. All you need to know, it's just like a format or a protocol that your radio uses to transmit your voice to another radio. Much older radios used AM, just like broadcast radio. And some people still use that today, but it's more of a novelty. It's not something you really have to worry too much about. It's nice to have, and it's included in pretty much every single radio anyway, but it's probably not anything you're really going to use that often, if at all. FM is another mode, and it's almost never, if ever, used in HF, but it is the mode that's almost always used in VHF and UHF. This is another thing where it's really only important to check for if you're using very old equipment. Almost all VHF and UHF radios, if they were made, past the mid-'80s, are going to be exclusively FM radios anyway. I mean, I've got a couple radios that only do sideband or AM on VHF and UHF, and they're basically useless now because I don't think I've ever heard anybody using those modes on VHF and UHF. So VHF and UHF are pretty much exclusively FM, and that's the exact same mode that FM radio uses. And speaking of old equipment, there's another huge thing you got to consider. I've seen a lot of people buy these old ham radios off eBay, and then they find out they're broken and they don't know how to fix them, and then it just becomes like a giant paperweight. And there's absolutely nothing wrong with buying broken old radios if you know what you're doing, you know how to fix them. That's pretty much exclusively what I did. Is all my radios are really old tube radios that I've brought back to life. And you can do that. There's lots of resources. There's tons of documentation. There's forums. There's technical manuals, there's schematics. If you're technically inclined, it could be really fun to work on these radios, especially because these older radios were built the same way that older cars were, and that was with user maintenance in mind. They weren't just built to be how cheap can we manufacture this and sell as many units. It's before capitalism went full retard, and so it's quality parts, easy to work on. The aesthetics are usually nicer, in my opinion. You miss out on some of the modern features, but the components are straightforward. Everything's easy to work on, like the older cars are easier to work on. But just like the older cars, the parts sometimes are harder to find, specifically tubes. They don't make tubes anymore. So if you get an old tube radio, you got to make sure that the tubes aren't bad, or if they are, that you can get new ones that don't cost more than the actual radio. They haven't made these tubes in decades, so the parts that used to cost maybe a couple dollars 40 years ago can now cost hundreds of dollars, if not more. So bottom line, if you get an older radio, you have to know what you're getting into. And if you're getting, quite frankly, if you're getting a radio for emergency communications, I wouldn't rely on some 40 or 50-year-old radio unless you had a backup. And that's what I do. I mean, I do rely on the old, and I'll tell you, another reason why these older radios are attractive, at least from my standpoint, is if you get an old enough radio, and this is like a really slight chance this would ever happen, but whatever. It's they're EMP proof. If you want to know what an EMP is, it stands for electromagnetic pulse. And it's what happens when a nuclear device is detonated. And there have been people, I think, honestly, mostly scaremongering, but, it is possible that if an enemy wanted to attack the United States and really cripple us, all they'd have to do is create an EMP explosion. And the way they would do that, it's theorized that if they were to detonate an atomic device, a nuclear device, above a city in the atmosphere, so it doesn't even have to actually hit the city, they could just blast it in the atmosphere above the city. And what would happen is that electromagnetic pulse would disable all of the electronics in that city, because these electromagnetic pulses destroy transistors, and which are in everything. So you can see videos on YouTube of people making their own mini electromagnetic pulses to blast, iPhones and stuff like that. So it does happen. It is real. The chances of that happening are pretty small. But if you are someone that wants to make sure you cover every kind of scenario, you get an old enough radio, and it has to be really old, because even a lot of the radios with tubes in them still have at least one transistor in it. But you get an old enough radio, you can get a radio that doesn't use transistors, or you can get a radio that uses maybe like one transistor, and you're kind of rolling the dice at this point, but these old beefy transistors aren't like the miniaturized sensitive transistors of today, so they're a little more tolerant of these blasts. But also these older radios are built like tanks, so they've got essentially a protective metal casing all around them. So long story short, the old radios potentially are EMP proof, which is a good bonus. Practically speaking, though, especially if this is something that you're going to just have ready to go in case of an emergency, it's probably not the best idea to rely on something that's 60 years old. Okay, so now that we've gone over most of the basics, the last thing to keep in mind is if the power grid goes down and you don't have solar or a generator, you can have all the radios in the world and it doesn't matter. Even the low power radios need some power. Worst case scenario, you can usually get power from your car, but transmitting is going to take a lot of power, and in an emergency situation, you probably don't want to be just running the engine, wasting gas, just so you can transmit on your radio. So I'd recommend getting at least a small solar setup. Solar generators are silent. They won't give you away like a gas generator would, and they won't run out of gas the way that a gas generator would. You don't need anything too crazy. If all you're running is a ham radio, it's not like you're going to be trying to run your dishwasher if there's an emergency. I mean, that's probably going to be pretty low on your priorities list. You don't need a whole lot to keep a ham radio and maybe a cell phone and stuff like that charged. The only time it's really going to be drawing power is when you're transmitting. And there's not going to be a whole lot of situations where you're constantly transmitting. So you don't need anything too crazy, but definitely keep power in mind, because a ham radio with no power is worse than a gun without ammunition, because at least with a gun with no ammunition, you can still use the gun to scare people. A ham radio with no power is just a metal box. So to recap once again, antenna tuner, radio, and power. And last but not least, I need to remind you that you need to be licensed by the FCC to transmit on a ham radio. Now, in an emergency situation, they do make an exception, of course, but you're not going to be able to operate a radio without practice any more than someone's going to be able to be a sharpshooter having never shot a gun before. You can't just expect to get a radio, throw it in a box, and then when an emergency happens, just know exactly what to do and how to use it. It's always good to have some practice. So the reason you might want to get a license isn't so that in an emergency situation you have a license, because it's irrelevant at that point. It's so that you can practice with your radio. So you have to understand that no one's going to respond to you on the radio when you're practicing if you don't have a valid call sign. So you won't know if anyone can hear you. I mean, sometimes they ignore you when you have a valid call sign. So you have to have a valid call sign if you expect anyone to respond to you, give you a report on how your audio sounds, help you work out any kinks that you might have. So getting licensed is something that you should consider. It's handled by local ham radio clubs, and it can sometimes even be free. You can visit ARRL.org, and that's the American Radio Relay League, and they'll have all the information that you'll need to go take the test in your area. The license is broken up into 3 different levels. There's technician, general, and extra. Now, to talk on HF, you need at least the general. If you do what a lot of people do and just get the technical because you're intimidated by the general, which doesn't make any sense, and I'll explain why in a second, you're limited to just talking on those walkie-talkie style local communication VHF, UHF ham radios. So you can't even use the HF radios until you have a general or an extra. The difference between general and extra is you're allowed to talk on slightly more frequency ranges when you have the extra. I mean, in fact, if you're going to go take the test, you might as well try to get the extra while you're there, because you can take one test right after another. So if you want to take the general first, and you pass it, you can take the extra right after if you want. It's no big deal. Even though a lot of people think it's a big deal, they think it's intimidating if you're not an electrical engineer. But first of all, they don't make you learn Morse code. They haven't made you do that since like the 80s or 90s or something like that. I don't know. But that's just a myth. You don't need to learn Morse code to get your license. The other thing is they give you access to every single question in the pool of questions that could be on your test with the answers. So there's like this pool of questions. It's a lot of questions. It's like, I don't know, maybe 200 or something like that questions. And they pick 20 randomly from that pool to ask on the test. But they give you the questions word for word and the answers word for word that are going to be on this multiple choice test. So technically, and a lot of people do this, you could just memorize all the questions and answers using flashcards, or there's apps even. There's an app in the Apple Store. There's an app in the Play Store. I forget the name of it. There's actually a few apps that they're all just like this, where it's just repetition. It'll just generate randomly these tests from the real pool of questions, and you can just keep taking them over and over and over again on your phone. until you start to consistently get them right, just through rote memorization. So once you have it to where you're consistently passing every single test, just go in and take the real one. It's the exact same questions, exact same answers, in the exact same order sometimes, and you get your license, and that's that. Now, obviously, I recommend understanding the information that's in the tests, but just don't let it freak you out. It's real easy to pass these tests, and if you need to lean on memorization a little bit, look, most people do. I really doubt most of the people passing the test actually understand all of the answers that they're giving, which might make some people mad, but it is what it is. Now, I also know some people are going to freak out because they don't want to register anything with the government, but it doesn't matter. They already have your information. If you think the government is now that they've got you registered with the FCC to get your license, now they're going to get you. Now you're on the list. I mean, you're just being insane. You're already on any list that's going to be bad. You're already on that list. If you get a gun, they have to do a background check. You think that doesn't put you on a list? You think coming to my channel doesn't put you on a list? Don't worry about the list thing. You're already on a list. If that's what's stopping you from doing it, I think that's silly. Now, speaking of the FCC does a terrible job. In fact, it kind of seems like they don't even do any job of policing the airways. And people do broadcast illegally all the time. On 80 meters specifically, there are some pretty famous illegal broadcasters. And they've been wreaking havoc on the airwaves for years with no consequences. So there is evidence that you don't need a license, okay, to broadcast. I'm just saying, from a practical standpoint, pretty much nobody's going to respond to your transmission if you don't have a call sign. People can, and they will, look it up to make sure it's valid before talking to you. So if you want to get practice, and I think that's really important, that you need to get practice talking to people, getting feedback about how you're sounding to other people, seeing how far out your radio can transmit, or the signals that you're able to receive and from how far away. Suck it up and go over the questions, maybe get one of those apps, take the 20-question multiple choice test, and get your license. So hopefully this answers a lot of questions. It kind of covers the basics of ham radio, might explain a little bit as to why it might be important to have this as a communications option if there is a problem, and also explain that it's not as simple as just picking up some $20 cheap radio off eBay and putting it in some box with your ramen noodles and whatever else and hoping that that's going to actually be useful if there's an emergency. Being proficient in ham radio is a skill, just like any other skill, just like knowing how to handle a gun. And just like with knowing how to handle a gun, there's more to it than just pointing and clicking. You have to know how to actually clean a gun, how to maintain your gun. The same thing is true about the ham radio stuff. If you want to know more about ham radio, there are endless YouTube channels dedicated 100% to ham radio, giving out their information. Really nice people. I suggest you check it out. In the meantime, I hope this at least answered some of your questions and covered some of the basics. For Blackpilled, I'm Devin Stack. If you like my videos, make sure you like and subscribe. Make sure you share. If you want to support my work, you can either grab a copy of my book, link in the description, send some crypto to one of the addresses below, or become a patron at patreon.com/blackpilled or subscribestar.com/blackpilled.